Okay, so let's have a look at some special matrices. So the 0 or the null matrix is a matrix with all elements equal to 0. So you literally just write the 0 matrix is a matrix with all zeros inside. So for example, this is a 3 by 3 0 matrix. Or if you wanted, here is let's go a 2 by 3. So 2 rows by 3 columns, so that would be a 2 by 3 0 matrix. Very important matrix, it'll come up a lot. It's called the identity matrix. Is a square matrix, that's important. It always has to be square. It's a square matrix with 1s on the leading diagonal and 0s everywhere else. What is a leading diagonal? Well, it's a diagonal, right? So for example, a 2 by 2 identity matrix, so we use the capital I for identity. So it has 2 rows, 2 columns, so we go 1 0 0 1. So this is your leading diagonal, and then zeros everywhere else. So that is your leading diagonal. For example, if we wanted a 3 by 3 identity, so it's 1 0 0 0 1 0 0 0 1. So again, your leading diagonal, it's diagonal, and it's called the leading diagonal because there is a sub-diagonal, which we'll talk about later on. So yeah, so that's an identity matrix. Square, it always has to be a square matrix. It has 1s on the leading diagonal and 0s everywhere else. It does have interesting properties, which we'll talk about later on. Next, let's talk about the equality of matrices. So how do we know when two matrices are equal? It's only if and only if that they have the same order, so if they're the same size, and each of the elements are exactly equal as well. So for example, work out A, B, and C if these two matrices are the same. Alright, so we have A plus 2B, 13C, so a 3 by 1. And then this is also a 3 by 1. Yeah. So for starters, both matrices are 3 by 1 matrices, which is good. So they have the same order, same size. So if these two matrices are equal, then the elements, the corresponding elements should be the same as well, right? So yes, we've checked that they have the same order because they're both 3 by 1. And then it also means then that the elements are the same. So what that means is A plus 2B must be equal to 4. So that's our first equation. We also have that 13 is equal to 2A minus B. That's equation 2. And C is equal to negative 2, which is equation 3, because that's the third element there. We've worked out what C is. So to work out A and B, we have two unknowns, two equations. Let's simultaneously solve that. The easiest way, I prefer substitution, so I'm just going to rearrange. If you prefer elimination, go ahead. So from 2, 13 minus 2A, no, let's swap it the other way around. If I swap the B across, then B is equal to 2A minus 13. I'm going to call that number 4. So sub 4 into 1. So, So A plus, wherever B occurs, I'm going to shove that 2A minus 13 in. So I'm going to expand the bracket. So that's 4A, 2 lots of 3, 6, 26 equals 4. So 5A equals 30. So A equals 30 divided by 5. So A is 6. So that's sub A is 6 into 4. So we can work out what B is. So B is 2 times 6 minus 13, which is 12 minus 13, which is negative 1. So therefore, A is 6, B is negative 1, and C is negative 2. There we go. So first check two matrices are the same if and only if they have the same size, the same dimensions. And then if they do have the same dimensions, then the elements, the corresponding elements are the same.